Hello everyone, welcome back. So in this video, we are going to understand the power of 2, right? So it's a very simple one-line code, right? You can just write the code and it will work for you, okay? But let's understand how the code works, okay? Very first, the question is saying that power of 2. It means we have given an integer n and we have to return true if it is a power of 2. Otherwise, we have to return false. So let's suppose what is the meaning of this, okay? So let's suppose we have given here n equal to 1, right? So if we will put 2 to the power 0, we will get this one. So it is saying if this n is equal to this resultant, right? It means we will return true. If it is not matching, this n is not matching with the power of 2. So the power of 2 can be anything. So we can assume that power of 2 is nothing but x, right? So 2 to the power x should be equal to n, right? Means 2 to the power x should be equal to n, and this is what we have given. What we have not given, this x we have not given. If this x will be given, means what? Nothing we have to do. So little tricky we have. So I hope you understand what the question is saying that, okay? For example, we have given 16, right? So it is saying, okay, 16 is given. So what is the x here? You have to assume you will start from where? Let's suppose 0 to, if you keep going there, so 2 to the power 0 will get 1, 2 to the power 2 you will get 4, 2 to the power 3 8, 2 to the power 4 you will get 16, right? So we will, okay, 2 to the power 16, yeah, it is matching. Like that you can also do, right? But how, what is the easiest way, right, to do that? That we will understand. So let's suppose we have given this example. Given example 2 is good, right? So if we'll say n we have given is 16, right? So what is the binary of this? So if you'll say the binary number of 16 is what, we can take n we have given. If we'll represent this n, 8 4 2 1, and there will be 16. Remember, we'll take 0 0 0 0 and 1. Can we say that? So we'll say, okay, on this we'll put 4 zeros, right? Because this is based on this, you remember, 8421, and if we need 16 bit, right, we'll use this bit, right? 16. So this is 4. So this is 2 to the power 4, and we'll say n equal to this, means we are talking about with n equal to 16, right? So when 2 to the power 4 means power of this value gives you in the binary like this, means the binary of 16 is nothing but this, okay? If we'll do n minus 1, means how many? Just we need one bit less, right? Means we'll take one bit is less, this will be 0, and the rest of will come about 1 1 1 1. So this will become, this is n, then this will go n minus 1. Can we say that? So if we will operate bitwise on this, let's suppose we have 40 here, right? And then we'll take here 0, and this will become 1 1 1. So if you apply the bitwise AND, right, what will happen? 0 0 0 0 and 0 all became 0. So it is equal to what? It is equal to 0. Can we say that? Equals to 0, right? This value is equal to 0. Can we say that? So it's a power of 2. So we'll say, so it's a power of 2, right? So, so there is also a concept of what do you call, I forget the name, it is calling a pointer movement, you can say, okay? So we just need what, one bit of we have only one bit, right? There is only one bit we have given in this one, right? And here we have got, this is your n, and this is your n minus 1. Remember, here n and n minus 1 you have to, right? So there is only one bit, right? So what we are doing here, we are we are moving the pointer from left to find 1, right? So everything after 1 becomes, after this 1 becomes 1, right? So this is called pointer movement idea. Okay, so when you do AND operation, right, then there is no overlapping between 1 and 0, right? So what will happen? It become 0, and so we got 0. Okay, so this is where we are doing here. We are taking if n is greater than 0. So you know that if power of will take anything, it will be greater than 0 itself. Always power of anything you take, it will be greater than 0. So we'll say n is greater than 0, right? If we'll take power of any value, we'll get the positive value, and then we'll apply n and n minus 1, right? And if it is greater than 0, equal to 0, like this we have seen, we'll get what? We'll get a result 0. I hope you understand. Let's understand our negative case. Okay, for example, if we'll take n equal to take 18, a very good example we can take. So we'll say binary of 18 is what we will get. So if n is this one, so we'll say n is this, and its binary will become what? 1 0 0 1 0. How? 16 8 4 2 1, right? To make 18, this and this value should be 1. So we have made these two 1. Now take n minus 1, right? So for the n minus 1, if you operate on this one, what will happen? Just we need minus 1. Okay, means 17. For 17, we need this value, and this value is 1. So just take this. Gotcha? Now you apply the AND. So I will apply here. So let me clean this one. We'll say for n, it was 0 0 0 0 0. 1 left is there. This should be 1. Right? This is your n. And n minus 1 is 1 0 0 0 1. Now you apply the AND. If you apply the 1, what will happen? 0 1 will get up become 0 1 0 0 0 0 and 1. Means what it is not becoming 0. It is not 0. You can say not 0. 0 is not coming. So if it is not 0, means it's not a power of 2, right? And so and it's not power of 2, right? Because we tried this and we have not seen that it is not equal to 0. If it is not equal to 0, not equal to 0, right, it means what? We'll say return false. Okay, so that's all I have in this video, and let's understand the time complexity and space complexity. Let me clean it. Okay, so what we are doing, guys, here, very first we'll check the positive checks. So the power of 2 are always positive, right? So we are taking n is, if n is, let's suppose n is greater than 0, it means what? The power of 2 is always positive. So if we'll take n is less than equal to 0, it will return false. Okay, then we have the bitwise check, right? So we are checking single bit, that we have seen, right? We are checking single bit, right? The condition n and n minus 1, give me 1 second, means n and n minus 1. So this result should give always is 0. If this condition checks working fine, means we are checking single bit, right? So single set bit we are checking, right? And so we'll say this check works, and we are getting one set bit we are getting, right? So this is fine. Once this is done, means both conditions are true, just return 0. I hope you understand, right? And for the bitwise operations, right, it will take just what you call time complexity, TC, right, is O of 1, and space complexity OS SC, right, it will give you O of 1, because we are not taking any extra space. Okay, thank you guys, thank you for watching this video. Please hit subscribe this channel, and let me know in the comment section that you like or not. and I'll see you in the next video. Bye bye.